back to Spring Into Math 8. Today is Content Review, Part 1. The first topic we talked about in this chapter was linear equations with one variable. So what you should know first about linear equations as a review is that there are three different types of solutions that you can have. There's a one solution, a no solution, and what we call many or infinite solutions. And we're going to go into that a little more deeply in a moment. So how many solutions does this equation have? We have 18 equals 2, and inside our parentheses we have b plus 6. So the first thing we need to do is apply the distributive property to get our solving started. So 2 times b gives us 2b, and 2 times 6 gives us 12. So our equation so far reads 18 equals 2b plus 12. Now we need to get all the variables on one side and all the numbers or constants on the other side. So to do this, we're going to subtract 12 from both sides of our equation. It's important to remember that if we do something to one side of the equation, we must do it to the other in order to keep our equation balanced. So when I subtract 12 from both sides, I get 6 equals 2b. And then if I divide both sides by 2 to separate that 2 and the variable b, we get b equals 3. So in this particular situation, we have a one solution answer to our equation, which is 3. Topic 2. Linear equations with multi-step equations. We have seen it so far that we can solve for an unknown variable. It takes just 1 or 2 steps to get to the answer. But we also have to remember there are more complex and difficult equations out there where it may take many steps, or what we call multi-step. Here's an example. 3p plus 4p plus 37 equals 79. So let's get started on solving this. The first thing we need to do is combine what we call like terms. We have 3p and 4p, and if I add them together, or I collect them all, I'm going to have 7p's. And then I bring down the rest of that equation so we can continue solving it. So we have 7p plus 37 equals 79. Now again, we're subtracting 37 from both sides, so we have variables on one and numbers on the other. 79 minus 37 gives us 42. So we have 7p equals 42. And we divide both sides by 7 to get rid of the 7 on the left side of our equation, and that results in p equaling 6. Here's another example. W plus 12 equals 40. Now, we need to collect like terms first. So when we collect our like terms, we get 2 w's, and then we bring down the rest of that equation. Plus 12 equals 40. So again, variables on one side, numbers on the other. And I subtract 12 from both sides in order to keep my equation nice and balanced. And then I subtract 12, I get 2w equals 28. And again, we need to divide both sides by that number 2, the number in front of our variable. In this case, it's w. So when we divide by 2, we get w equals 14. Topic 3, solving linear equations by graphing. So in a review, we have previously talked about y equals mx plus b, where the m tells us what the slope is, and b tells us where the line crosses the y-axis, or what the y-intercept would be. So let's look at these two equations and then go ahead and graph them. We have y equals 3 and y equals 4 over 2x minus 2. So here we've graphed y equals 3, and that's a nice horizontal line, which every value for y we get that number 3. So it does go along with our equation y equals 3. Next, we've graphed y equals 4 halves x minus 2. Our y-intercept is negative 2, so we start right there. Then our slope tells us to go up 4 spots and over 2 to the right, drop another point. And from that new point, we go up 4 spots and over 2 more to the right. And that's enough points on our graph for us to connect that line and get a nice image of what that equation looks like. When we place them both on the same graph, we can see that they cross. And that's what we want to see. We want to make sure that those equations are crossing, and where they cross is our exact answer. And in this case, it crosses exactly at 2.5, 3. That's it for review part 1. See you later.